Welcome to Spring LIB.
In this question, we are considering the decay of a muon into an electron with two neutrinos. Now we want to find what is the maximum kinetic energy that is possible for our electron. And to do that, we will first need to consider the case, right? That will give us the maximum kinetic energy for the electron. Now, a big hint that was given in the question is that the muon decays from rest, and this tells us that the momentum of the initial system is zero, and by conservation of momentum, it must be zero for the final states as well. And by conservation of momentum, in order to give us the maximum kinetic energy, our electron must have the maximum amount of momentum as well, right? Because kinetic energy is p squared over 2m, is related to the momentum. So what this tells us is that the electron must be directly moving in opposite direction to two of both the muons, both the neutrinos, in order for it to be able to obtain the highest possible momentum without breaking the momentum conservation law. Alright, so now we need to write down the various conservation law, which is the momentum conservation. Momentum of the electron must be equals to momentum of the neutrino right? And the second conservation law, I'm going to use conservation of energy. So the initial energy is just the the rest energy of our muon. The final energy, when we equate this to the final energy, is the total energy of our electron plus total energy of the neutrino. Sorry, this should be an anti-neutrino, plus the total energy of our muon neutrino. Now we're going to find what each of them individually are. So for electron, the energy of the electron by the mass energy relation is equals to the momentum square, c square, plus its rest energy squared. For our neutrinos, because they are massless, they do not have the rest energy, so their total energy is only made up of the momentum. Right, so just right, so this is our energy equations. Next, what we want to do is to substitute all the values into our energy conservation equation over here. But we know that by momentum conservation, this is true, right? And so this means that E of V mu, right, the total energy of our muon momentum plus energy of our anti-neutrino is given as right. This is equivalent to just momentum of the electron, right, multiplied by c. And now if you were to convert this, right, this thing over here using our energy conservation equation is actually equals to the rest energy of our muon minus away the energy, sorry, it's not this but just this two, right, over here is equals to rest energy minus total energy of the electron. Now we can square both of these expressions, and what we get is P square C square is equals to right, and we want this expression to be substituted from this expression over here. So we just rearrange to make this the momentum of the electron the subject of this equation, and then we substitute into our equation over here. Right, so this is equals to this. We equate everything nicely. And we find that the total energy of the electron squared appears on both sides of the equation, so that we can get rid of it, right, and simplify the equation a lot. So everything is now only the total energy of the electron is the only unknown in this formula. So we just have to rearrange energy of the electron. We bring it to the left hand side, and then we have C square divided by 2 C square. Now we know that the total energy of the electron, like total energy of the electron, is made up of the kinetic energy plus the rest energy. So what, in order to get the kinetic energy, we just have to substitute the total energy, right? Substitute the using the total energy, subtract with the rest energy of our electron to get the kinetic energy. So the kinetic energy is just the total energy expression minus away the rest energy. And now what we have to do is to substitute the rest energies in. So rest energy of the electron 0.511 MeV. Rest energy of our muon is 105.7 MeV, and that's all we really need, right? It's really just 0.511 square plus 105.7 square divided by 2 times 105.7 MeV. So this in terms of MeV, and we should get 52.3 MeV as our final answer.